So for page 345, number 9, we're given 2 points on line L, and then we're asked to find the missing values for the variables so that a third point is on L. And in part A, the third point, which we'll call point T, is 3 comma A. So we have to find the value of A so that T is on line L. Well, in order for T to be on line L, we know that the slope of the line through points R and S must be equal to the slope of the line through points R and T. The slope of the line through points R and S is rise over run, which is change in y, which we can do as 2 minus 4, and divide that by change in x, which is 6 minus negative 2, and that is negative 2 over 8. And the slope of the line through points R and T is a minus 4 over 3 minus negative 2, which is a minus 4 over 5. So now we have an equation. We want to solve for a. Several different ways we can do this. We can do backtracking because a variable shows up in only one place. So we can multiply both sides by 5 if we wanted. You could also do basic moves. You could also get the units the same. So a lot of different ways to solve this. So we get negative 10 over 8 is a minus 4. And then the a is, we're subtracting 4 from the a. So to undo that, we're going to add 4. Those are not the same units, so let's multiply the 4 by 8 over 8. So now we have negative 10 eighths plus 32 eighths, which is 22 eighths, is equal to a. If you wanted to simplify that to 11/4, you can, or we can leave it. Okay. So for part B, our point T is 5 comma B. So we can set up an equation exactly the same way. We already know that the slope of the line through points R and S is negative 2 over 8 because we just did that work. And that has to be equal to the slope of the line through points R and T, which in this case is going to be change in y, which is b minus 4, all over change in x, which is 5 minus negative 2. So negative 2 eighths is equal to b minus 4 over 7. Just to show this a little bit of a different way, why don't we get the same units here by multiplying the right side by 8 over 8 and multiplying the left side by 7 over 7. Negative 14 over 56 is equal to 8 times b minus 4 over 56. Because they're both 56ths on both sides, we don't even have to worry about the units. So this tells us that negative 14 is equal to 8 times b minus 4. You could also get that equation by multiplying both sides by 56. And now, I'm going to take negative 14, divide it by 8, and then add 4, and that's b. So that's with backtracking. And if you want to get the units the same here too, we can negative 14 over 8 plus 32 over 8 is equal to b, and so that is 18 over 8 is equal to b. Alright, I'm going to do part C sort of the same way because there's a little bit of a difference here, and then I'm going to show a shortcut that we could use for all of these, including the ones that we just did. So for part C, our point is C comma 8. Alright, so our slope of the line through R and S we already know is negative 2 eighths. and our slope of the line through RT is, let's scroll back up and see what our point R was, negative 2, 4. So this is going to be 8 minus 4 over C minus negative 2. So now we have, we can simplify the fraction on the left if we want to, by the way. Negative 1/4 is equal to 4 over C plus 2. So in this case, we have our variable in the denominator, which doesn't lead us to be able to backtrack or basic moves for this. So we need to get the variable out of the denominator. So we could multiply both sides by C plus 2 if we wanted. We could also take the reciprocal of each side, so we could rewrite both the left side and the right side, which is a fairly straightforward way to do this also. But I'm going to assume that you didn't see the reciprocal piece, and let's say we just multiplied by C plus 2 and C plus 2. And so now we have C plus 2 times negative 1/4 is equal to 4. And by backtracking here, I'll take my ending number, I'll multiply it by negative 4 to get rid of the negative 1/4, that's multiplied by the reciprocal, and then I'll subtract 2, and that will be my starting number. So I use some backtracking there. So in this case, C is equal to negative 16 minus 2, which is negative 18. All right. So now I'm going to show a way that's a little bit more straightforward for this, and that is, at this point we can sort of recognize that we're doing the same thing every time, which is basically setting up this point tester. So our general process here is that the slope of the line through the points R and S, which is negative 2/8 or negative 1/4, either way, needs to be equal to the slope of the line through R and T. And so this is basically our point tester. No matter what our coordinates of T are, we're going to end up with this y minus 4 over x minus negative 2. And in all of the previous problems, we just plugged our y value in for the y and our x value in for the x. And then we used that equation and solved for whatever value we did not have. So I'm going to take that equation now and just rewrite it so it looks a little simpler. So first I'll do x minus negative 2 and change it to x plus 2. Then I'm going to multiply both sides by x plus 2 to bring the x plus 2 up onto the left so it's not in the denominator, sort of like what we did in part C. And now I don't really like that negative 1/4 on the left, so I'm going to multiply both sides of the equation by negative 4. And that's going to cancel out the negative 1/4 on the left, so I'm just going to be left with x plus 2 on that side is equal to negative 4y plus 16. And why don't we move that negative 4y over to the left side, and we'll move the 2 over to the right side. So adding 4y to both sides and subtracting 2 from both sides is, and we get x plus 4y is equal to 14. Right? And so that equation is the same equation that we had before, but it's just a simpler, easier form to use. So now we could use that equation for all of these problems, including actually the 3 that we've just done. So if you notice that at the beginning, it shortens all the work that we've just done. So let's use this and see that it's shorter. So for our point in D, we have 7 comma D. So So we plug 7 in for x and d in for y. 7 plus 4d equals 14. And now let's use chunking here. So 4d must be 7, which tells us that d is equal to 7/4. And then we can do the same equation for the other ones. So for part E, we have our point 13 comma E. So 13 plus 4E is equal to 14, which tells us that 4E must be 1, which tells us that E must be 1/4. And for part F, we have 120 comma F. So we have 120 plus 4F is equal to 14, which means that 4F must be 106, and that tells us that F needs to be 106 over 4. You can see actually here chunking makes all of this work super quick in terms of just looking at it, as opposed to subtracting 120 from both sides and then dividing both sides by 4, although that works perfectly fine and is still great to do this. Okay, so G is x comma negative 2. So we can do x plus 4 times negative 2 is equal to 14, or x minus 8 is equal to 14, and so x must be 22. And so h and I are very similar to that, so I'm going to just skip those two, and we're going to jump down to point J, which looks a little bit more complicated, but is not so bad either. So for J, the point that they give us is v comma v plus 1. We're going to plug that into the same equation, x plus 4y is equal to 14. So we get x, which is v, plus 4 times y, which is v plus 1, is equal to 14. We can use the distributive property here, so v plus 4v plus 4 is equal to 14. We can combine our like terms. 5v plus 4 is equal to 14. 5v must be 10. V must be 2. For k, our point is w comma 1.5w. And you know, since I like fractions, I'm going to immediately rewrite that as 3w over 2 as our point. So our equation becomes w plus 4 times 3w over 2 is equal to 14. The 4 and the 2 cancel nicely to just be 2. So w plus 6w is equal to 14. 7w is equal to 14. W is equal to 2. And for our last one, we have u comma u plus 14. U comma u plus 14. And so x, which is u, plus 4 times u plus 14. We want to equal 14. U plus 4u plus 56 is equal to 14. 5u plus 56 is equal to 14. This means that 5u is equal to negative 42 using chunking, or u is equal to negative 42 fifths. And that's the problem.